time and maintenance need as well. Moreover, it provides a backup and recovery systems that create automatic backup of data from hardware or software failures and can restore the data if required. Plus, multiple users can means it provides different types of user interfaces. Multiple users can access the data whatever we have. Our next topic is database system applications. It can be used in banking. For example, if we have to save some customer information, some account details, some bank loan details that we can save in it. It is also used in airlines for reservations and schedule informations. It is also used in universities for student information, to keep student information, to store the course related information, to store some of the registration related information and grades of the mark sheet, etc., etc. It can also be used in telecommunication for keeping records of call made, generating monthly bills, etc., and many. The further usage of applications of database system is in finance for storing information about holdings, stacks, sales. Also in manufacturing for management of for supply chain and tracking production of items in factories. Like this many amount of items are produced in one day, in 1 month, in 1 week. To keep track of that thing, we can use DBMS. Our next topic is data abstraction. So for the system to be usable, we must able to retrieve data efficiently, and this need of efficiency has led designers, developers to use complex data structures, algorithms. Since many database system users are not computer trained, that much trained from the computer. So to simplify user and database interaction, the developers hide the complexity from users through several levels of abstraction. So there are 3 levels of abstraction here: physical, logical, and view level. We'll see a diagram. This is the view level, logical level, and physical level. The physical level describes how the data is actually stored. Okay. The logical level describes what data is stored in the database, and view level describes or it shows only that part of data which is to be shown. The next topic is DBMS terminologies. The first terminology is data independence. It is defined as property of DBMS that helps you to change the database schema. Now what is schema? Schema is the overall design, the structure of database. This is called a schema. And data independence is a property of DBMS that helps you to change the database schema at one level of a database system without requiring to change the schema at higher level. Okay. The next is instance, database state, or snapshot. Databases change over time as information is inserted or deleted from it. Okay. The collection of information stored in the database at a particular moment is called instance of the database. Our next topic is DBMS architecture. There are 3 types of architectures: 1-tier architecture, 2-tier architecture, and 3-tier architecture. 1-tier architecture in database is directly available to the users, means the user can directly access the DBMS and it can use it, like that is the client, server, and the database all present on the same machine, like that way. The next is 2-tier architecture. The 2-tier architecture is similar to basic, we can say, client server model. Like it has front end and back end. The client is the front end and server is the back end. All the processes are performed, are programming in the server model, and all the UI and all the stuff the users can consume are all present in the client side. The third one is 3-tier system. There's another layer between this client and server side. Means the advantage of this is there's no individual connection between this client and server system. There's an intermediate layer that acts as a medium for the exchange of partially processed data between server and client. It is also used to maintain some data integrity, and it also improves some security.